helping you with Acorn and RISC computing.
Ready to rock and roll. Over to it's all yours.
Jolly good. Well, thank you everybody for turning up or tuning in, or have you attended? It's my first talk, so I hope it goes okay. No doubt there'll be some technical issues, but we'll have to see how we go. So I'm going to start with a little bit about me. I don't know how much people have seen any of my other stuff. I started using RISC back in RISC 2 days with an A3000. We had a couple at school, and like most of us, I think we mainly used them to play Lambda. I sort of started dabbling in BASIC on those machines, having used BBC Basic a bit beforehand. From there, I progressed on really through a bit of assembler, and finally onto, I guess, C and C++ on the RISC machines. I got a hold of the early compiler, the early C compiler, and which I think was the one that at least came with RISC lib, so you could do desktop programs, which is kind of where I kind of started doing actual, what I would say, serious development. I did quite a few bits and pieces for mainly for special programs, which you may have seen or may have used. A couple of them were BDFS, if anybody remembers that from RISC PC days, which I think Claire's was sold through Claire's. It's probably one of my ones that people have probably heard of. There's a couple of network type things that I did in conjunction with school, to helping the school manage their let's say Ethernet network. It was Ethernet, but it was AUN network. So there was a couple of things. There was an admin suite which I sold in adverts in Acorn User and stuff like that. So basically, I kept with the RISC sort of world until Acorn's demise, and then actually a bit beyond that. But like a lot of people, I think we kind of, a lot of people drifted away, using whatever Linux or Windows or a combination of those. So when the Raspberry Pi came out, and there was a RISC port for that. That's probably when I sort of got back into using RISC at all, really. So I got hold of a Model B. I've still got it somewhere. It's in a box over there somewhere. So I got hold of a Model B Pi and put the RISC SD card in it and flashed it off. And I thought, so going back to the desktop, and kind of surprising how quickly it all came back. So that's sort of when I got back into the RISC sort of world, as it were. So I'll have a drink. So in the time away from between early 2000 and whenever the Pi came out, obviously I've been continuing programming varying languages. Mostly it was C++ and C. But then I started to use Python. I was aware there was a port of Python for RISC OS, but it was I think even at the time, it was quite an old version. It was, I think, 2.4 or something like that. There was a later port, I think, a version 2, but that was the one that was out. And I think by the time I'd sort of got back to trying to program or anything on RISC OS, the Python 3 had been out for a while, and there definitely noises in the Python community that Python 2 is on the way out, and we're not really going to do anything with it anymore. It's not really going to support it. There's quite a big push for everybody to move over to Python 3, and unfortunately for us, I guess, in the RISC world, the change from 2 to 3, the Python lot had dropped the RISC stuff out of it. I think that was probably because there was no one to maintain it. I'm not entirely sure. That was my my understanding. So, we couldn't just get hold of it and compile it like you could have done before then, I guess. So why Python, I guess, was when I started to use it, I found it very I'd say an easy language, but you can do a lot with it fairly quickly, sort of compared to writing things in C or C++, where you can, spend a lot of time bashing code, compiling it, doesn't work, whatever, especially a cycle of that. And especially in C++, where you can write some code and spend ages trying to get it to compile because the compiler's giving you 4 pages of errors every time you do something. So with Python, it was a lot more. There's a lot better feedback loop, I guess. It's a bit more like BASIC from days of yore when you could, type something in, run it, see what happens. So that was certainly an easier way of sort of getting results quicker. This is where I'd used it elsewhere. So there was, and I thought, well, can we use Python on RISC? Well, at this point, the sort of answer was yes, but it's the old version. So with that in mind, sorry, look at my notes, which are there. Decided to, see how hard can it be, as they say, to try and get Python, Python version 3 to work. The actual getting it to build was fairly easy. Getting it to run was the tricky bit. The building side of it, I think I used the cross compiler initially on the Linux machine. There was the code base for Python really does assume you're running on Windows, Mac, or Linux, or Unix. They're the sort of top level platforms. So if you're not one of those, you got to kind of modify varying bit. It wasn't too bad. I mean, there's the Windows and Mac are separate make files and stuff anyway. So I managed to sort of modify one of those enough to modify the Windows one enough to run it and to build it. So I think it actually just compiled, but and then of course you try to run it and it falls over in a big heap. Perhaps not surprising considering how different things are. So I think after quite a few bits of debuggery, as I call it, trying to go through varying issues, trying to get it to run rather. I did eventually get to the Python prompt, which is 3 arrows or 3 chevrons, whatever they're called, which was quite a big milestone in just getting that far, because actually, to get to a prompt, a lot of the interpreter has to be up and running. There are a lot of things it has to do just to get that far. So that's quite a milestone. In fact, when I first got it to get that far, it was just 5 or 6 pages of a task window with a prompt at the end, because there's lots of debug and stuff in at that point. So, and that was the first step. And I think I did post onto the forums at the time. There was some talk on the forums around, is there a Python 3? Is anybody doing Python 3? So I sort of posted onto the thread of chat. I think there was a couple of threads going around at the time, but so going to sleep. One of the big things that's different between RISC OS and certain other operating systems, like all of them, is handling of file names and file paths. When that has been a big part of, I won't say that, the challenge of getting Python to work cleanly and properly. Obviously, where we have, file types and paths separated by a dot, as they should be, Linux and Windows do it differently. We have file extensions and slashes or different slashes. And because the Mac is pretty much Unix underneath, that fits the Unix model. So lots of the Python code base is, if Windows do this, if not, do something else. So there's had to be quite a bit of shoehorning in at some places, or modifying bits of code saying, if you're RISC-OS, you need to do this instead. So there's also the thing that RISC-OS can have file types. So I wanted to have a type for Python files that you could just run them without needing to sort of do Python 3 thing/py or something to get it to run. So you could just double click a file, it would launch the interpreter, run your program. So that's easy enough. You can set the run type to launch it. That works. But the Python can also import. You can, if you use BASIC, you can do the library command to pull in another file and say, I want to use things from this. So in Python, it's import is the way you do that. But you can import other files. The way the import mechanism works is smoke and mirrors and like magic, I think. But that's the best way of describing it. The other interesting thing is the import mechanism is written in Python. So which has caught me a bit by surprise, because how do you import stuff if it's in the language you're importing? But, the answer is it gets compiled in. So there's a separate build step which converts the import stuff into compiled code, which is then built into the executable. Onto that later. So the import mechanism was probably one of the things that had a fair amount of hacking to get it to work, shall we say. I'll sort of touch on that a bit later on. But I really wanted to sort of support native RISC-OS names, file types, then things would just work. This is perhaps making my rod for my own back in a way, because I ended up turning off all the Unix lib translation stuff, file name translation stuff, so it does everything in RISC-OS names. I just found that with the auto translation stuff, it was very easy for it to get confused, and that was so I just ended up turning it all off and did it myself. But that meant a lot of things had to be at least looked at. One of the things in the Python code pretty much throughout is there is actually a variable defined to be the extension separator, but nobody uses it. Everybody assumes it's the extension separator is dot, so it's thing.py or whatever. And so there's a lot of things that you can just trip you up there, because if you just take a directory name and add a file name and add .py on the end of it to RISC-OS, that means, well, it's a directory with a file in it called py. So that was that's I won't say it was particularly hard. It was just a lot of instances of it where you try something and it fails. Obviously, you can. I did try several ways of sort of magically handling that, but it's very easy to design something that works for one case, then falls over on the next one. So in the end, I just kind of did a very simple. I think if you're trying to open a file, if you're trying to open a file dot something and it's not there, it'll try swapping the last dot for a slash and try that, and it's not there. It just says, I can't find it, give up. I think as soon as you try and do anything more clever or complicated, there's just too many edge cases and too many times where it'll almost work or not work. And it was just easier to say, no, we'll just do it. We'll just do it RISC-OS file names and deal with it that way. So that helps. Mainly had to put that into just to stop. I just found I was just going through every file, changing it from dot something to except. There is actually a defined variable for extension separator, but nobody uses it because it's always dot, right? So it's not. So with that done, the way I've done some of this stuff in the import system is it's basically the import system in its complexity and what it does. It's very flexible, but it's also very there is lots of magic in it. The import system, I've extended that so it can import stuff from a file that's given a type, because actually it itself will only look for extensions. So if you try to import from hello, it would say, is there a hello.py? Is there a hello.pyc? Or varying other extensions that it can handle. But obviously, if you have a typed file, you probably won't have an extension on it. You won't have a /py or anything like that. So I did have to handle that, which broke a few assumptions in the import system. One of which was, if there's no extension, it's a directory. No, it doesn't have to be. But that was so I had so the way I've done that is actually there's basically so I didn't have to change the whole import mechanism too much. I ended up with what I've called an equivalence map, which is a mapping from file type to what the extension would be if you had an extension. So the type for Python files maps to basically .py. And then the import mechanism, the import system can then find them, use them, and it's then happy. So you can just import. So if you've installed Python, the stuff in the standard library is all typed. I can show you if I can share my screen. Let's see if I can do that. Share screen. There it is. Look. Let's go to that. Share. Right, we should have my Raspberry Pi. Now I can use the other mouse. So I'm probably going to look rather rude. I'm not looking at anybody, so I'm looking at the computer. Install it. I did install Python on this very recently. So I go into here in the Python library. These files are all typed. That's Python files. There we go. A73. You can import those. You can just use those as if they were, abc.py, for instance. There. So you get a nice, nice file window that everything /something in it. So it fits in more with how RISC works. And if you have your own program, own stuff you've written, you can have the types, have that stuff, and it will just work. That was quite a challenge to get that all to work. Initially, I just didn't bother. I just used they're all text files. They all had /py on the end. That was an easier first step. And then thought, well, hang on, it's not really RISC's way to just have files with /py on the end. So having done these files, so there's different ways of having Python code. The standard, the first one is these, which are script files. It's not the right mode. I think so. Yeah, it's a new install. So these are these is Python code. They're text. Type them in, run them, whatever. When Python runs one of those, it will convert it. It essentially compiles it into a PYC. If you have Linux or something, or Windows, Unix, they're called PYC files. They're compiled Python files. They're I think it's the script, but it converts it into bytecode. That's the bytecode it will run. So that's the same one, but in bytecode. It will cache them when it generates them, but you can also just ship the PYC files without the equivalent PYC files without the Python files. So you can just have the compiled version without the script. So you need to be able to use those. They're their own type, and there are also slightly more. Not there. These ones, very slightly hard to see. They've all got slightly different color icons. These are Python extensions. Now, these are actually C code that's been compiled that Python can then use. So, fairly common thing to do if you need to. It means you can use the sort of performance of just raw C, but use it from Python. So, the varying things in there, like, the compression libraries are in there. I think the socket wrappers in there. There's some math stuff. So these are actually compiled C. Loads of them are actually SO files. There would be SO files under Linux. There would be SO files under RISC as well, but they've got their own type. So they're all compiled in part of the Python. But when you build Python, it does build all these for you. There was a whole set of worms building those, however, because if I just share a different machine. Wrong mouse, you see. This is what happens when you have too many mice. So I guess I'll give you a bit of background on how it builds all these wonderful compiled C things. They are built from a Python script, which lots of bits in Python are built from Python scripts. I guess if it's what you have, you might as well use it. So I was going to show you a set of Python script. That's why I just change machines. Let me just get another VNC session. Come on. Yeah. Watch, it's on my ARM book, so I can't actually get it now. Just tidy the screen up. Oops. Bear with me just a moment. That's helpful. So the window, not where I wanted it. Let's drop that down. Can you see my other screen now?
Yes, indeed.
Jolly good. That's a start. This is sort of the nuts and bolts of it all. This is where I build it. It's all in Git anyway. So there's a setup script, which this magic, which is what it uses to build all the extensions. Obviously. There was a few things I had to, I won't go through it all, but there was a few things I had to change to get this to work. One of which is this. One of the things this script does is it works out which of the extension you can build, which it does by sort of checking what libraries you've got and what's available. So, which is a common thing it would do because it was sort of designed for Unix-based systems. It was looking /include, user include or user local include, and all these standard Unix places for files. And then, of course, RISC wouldn't find them there. So I had to do a bit of munging around to say, well, actually, if you're building on RISC, you need to look for libffi6 : or something instead of user include something. So that was fairly straightforward to get that far. But the way it builds stuff, there's one there. RISC magic to handle the fact that includes and they're in the H directory and things like that. So having got the script to really sort of run and try to build stuff, the way it actually does the building is it shells out to GCC or whatever the compiler is, but in our case it's GCC. So there was an issue there that you're then trying to. You've got a fairly big program in the sense of Python. You're trying to shell out to another big program, so GCC. And I think the implementation of fork was struggled a bit with that. I certainly had trouble with it. It sort of worked sometimes, or it would have issues with redirection and things. So in my notes, there's yak shaving here. It just sort of got more and more. I need to do this, to do this, and to do this, to do this. But this is where the task runner module came about. So if you've installed Python, especially the early versions came with it, sort of in the archive. It's now in Pacman, so you just install it and it's there. So the task runner was a way of trying to help with that. Because RISC-OS doesn't really have the concept of multiple processes and sort of controlling them. The closest we've got is the task window, but you can only use a task window if you're a desktop task. If you're running in a task window, self, you're not a desktop task. So going this route meant that I could use basically the task runner module is a desktop task, so it can invoke task windows, it can interact with task windows in a way that standard processes can't. So the idea is that the task runner thing handles the task window for you, and it feeds you data back, and you can feed data the other way to the task window you're running. So that meant that had that's a SWI interface on that, so you can therefore just use it from anything, as long as you're in the desktop. Obviously, not a desktop, you won't do anything. But I figured that most use cases of this are going to be in the desktop. So that was a compromise that I was sort of accepted. It doesn't do everything the Python submodule, which is how it does running other tasks. Doesn't do everything that does, but it did enough to get me to build the extensions, which is what it came about for. And it's been useful for other things as well. But that was to get these extensions to build. Having got the compiler to run, they actually built pretty much okay. I mean, they pretty much all build. The ones that don't build are the ones you probably wouldn't expect to build. The TK library doesn't build. It wouldn't. The curses library doesn't build. There's a couple of others that don't build, but I think all the ones that don't build now are ones that I thought, well, yeah, fair enough. That's not going to work. So that was fair. I mean, you can see there. Oh, you can't. Pointed the wrong machine. On here as well there. So you can see the ones that do build. There's most of the standard ones do build. Most of them, there's all the standard stuff that you probably would expect for standard Python 3 installation. That's all there. You can use them, run them, whatever. That was the second step, was having got Python itself to run, was then to get the extensions to run. I mean, that wasn't actually as bad as I thought it was going to be, because the new GCC uses ELF, it uses sort of more standard things. I did wonder if I was going to be down a dark alley of trying to find DLL libraries and stuff, but because we now have the shared libraries, that the system's capable of doing that. That bit of it was actually a lot easier than I feared. So that was a win in that sense, I guess. Just refer to my notes again. I guess going back to the whole sort of thing about file types. I remember there was a bit of a discussion on the forum about whether we use the existing type. There was a Python type anyway, but I think in the end I decided that Python 2 and Python 3 are pretty different languages, so they should have their own types. In theory, you can have them both installed at once. I'm not sure I've ever tried it. So these are new types of Python 3 as opposed to the existing types you had for Python 1, Python 2 rather, which in theory will now still work with Python 2. I say I don't think I've tried them both on the same machine. They should work. So we've now got Python itself and the extensions. So that was a sort of a good first step. I believe that was released in varying zip files and stuff that I put on my own website just to get some feedback off people. So that was the initial release was that lot. But one of the obviously that's okay for churning out things for a few people to test, but it's there were a lot of dependencies, and I think the early versions did have with them a sort of a file of you'll need to use Pacman to install this lot. But since Pacman can handle dependencies for you, it seemed sensible to put Python in Pacman, so you just install it. There was a bit of jibbing and throwing about what went in the packages. How finely do we split it up? So I think there are sort of two main packages plus one. I have Pacman installed. I could show you, but I can't see it because it's hiding. Just bear with me. It's pinned on my pin board, but I've changed the resolution, so I can't see where it's pinned. It's not good, is it? Okay. Let's search for Python. We go Python 38 and Python Core, the main ones. There's pip and pygame as well, which we'll get to in a minute. There are several bits in Python Core, which the idea is that you have Python Core, which is the main Python. The Python thing called Python 3 is actually in Python Core. There's also Python Site and Python User. They're all in the core, and then the idea is you have core plus one or more Python versions. So 38 in this case is the Python 3.8 effectively. So the Python Site and Python User are really has more to do with what pip can install. So I shall move on to that one next. Pip is the Python package manager. You can't just run it. Oh. Different keyboard. A laptop keyboard seems to assume that if you push F12, you want to control the brightness, unless you also hold down function. No, I don't want to do that. Pip 38. The version numbers part of the pip command, because if you have several versions of Python installed, you need to know which one you're using. So it's got lots of output when you run it. But the idea is you can install packages with it. So I'll spell. Yeah. It's not going to install. It's probably already installed, but never mind. Hopefully, tell me a minute. It's already installed. You can't do it. Okay, it's already there, but fine. So the idea of pip is you can install packages off the Python package index, which has got, I believe, 15,000 packages or thereabouts. So there's a lot there. Obviously, they're not all going to work. Sorry, they're not all going to work on RISC, but quite a few do. I guess there are two sorts of things on pip. There's on the Python package system. There are packages which are just in Python, which there's a fair chance they'll work. The usual issues are with file names. As I sort of said earlier, things just assume that Python files end in .py, files have always got extensions, slashes as separator, and they just make these assumptions that then the system, but that's not the case. It all goes horribly wrong or slightly wrong, but it doesn't always work. But you know, a lot of them don't. A lot of them are just fine. So there's a couple I've used. One for doing web requests, just installed it. It worked. It was fine. The other sort of package that I think that Pygame is, which is why it's its own package in Pacman. They're packages which have got C code with them, which it has to be compiled. Those are ones I don't currently do anything with. I'm sure it can be done, but at the moment it's just two different. You know, the file names are in the wrong places, the libraries are on the wrong places. So I've not actually tried to build one that's got code in it through the pip system. You can get the package, you can sort of munge the code around a bit, you can get it to build manually, which is how Pygame works. I think Numpy has been built in a similar way. I think I had other issues or something else, but so you can do it, but it's not something you can just do pip install Pygame, because it won't be able to compile the files. For start, they'll be in the wrong place. So if you've done any sort of C coding on RISC, you need the C files have to be in the C directory, header files in the H directory, which no other system uses. So you unpack the file for the package, and it'll helpfully put something /C and something /H, and then the compiler will say, can't find it. But that's probably a longer term aim would be to obviously to support more these compiled packages. But at the moment, it's the pure Python ones will generally install, will generally work. There's a couple which have needed sort of minor tweaks. I think it's one for certificates, which assumes a file's called cert.pem, which then goes into can't find directory called cert. So there's minor stuff which you kind of have to sort of munge a bit to make it work. But it's really I really should be upstreaming these things and saying, your package needs fixing. But whether anybody will actually pay any attention to that, I don't know. So maybe we need to do our own sort of wrappers or something. But for now, they don't pretty much just work. The Python, so it's my boot system. Yeah. The Python site contains things that you've installed with pip here. The layout of this is such that Python 38 and other versions would have their own. So if there was a Python 3.9, there'd be Python 39 there. Currently, you can't install things with pip on those, so there's nothing there. That's where it puts them all. On Linux and Windows, there's a concept of the system-wide packages you've installed with pip, and there's a concept of the user packages you've installed with pip. Now that's perhaps a lot less of a thing on RISC OS, because it's generally one user. We don't really have the concept of users, but I do support doing so. So I remember where it is now. It's not well. I can just show it. The boot choices. So there's think it gets put there so it's seen early on. This would be Python packages that were installed just for one user. So if you had a multi-user system, which sort of was a thing for Select, the concepts are there. I don't think many other. It's not widely used, but the idea is each user would have their own Python user. There'd be a system-wide Python site, or site-wide. Hence the name. What was a chat request? Oh, jolly good. Someone says they have got them both on the same machine. That's Python 2 and 3. That was the intention. Not sure how well it worked. So I have sort of allowed for user and site-wide packages to be installed. How much that's actually going to be useful, I don't know. But the facility's there. You could sort of use I think you do pip install -minus user to put it in the user area. So that you could, I guess, perhaps a more useful case would be you can install things in the user area that you weren't sure about, or you think you might want to get rid of it. You can, keep things slightly separated. But I sort of just put them both in on the grounds that it's better to have it there than kind of wish you'd put it in after the event. So. Stop sharing that now. So that was the sort of the getting pip to work was something else that I felt needed to do. It's a pretty key part of using Python is that you can use these packages. Obviously, you can run Python without it. You can just write your own packages, use a standard system library, but invariably you'll soon think, oh, I need to do this. There'll be a package for it. You're going to want to use the packages, not write your own from scratch each time. So that to me was quite an important thing was to get pip working. And it actually wasn't too bad to get working. Again, there's a lot of munging of file names. The way pip works is it kind of fits on top of stuff in the standard library. So it's quite a convoluted thing of stacking bits together. So, but having got all the bits, it did, it started, install stuff fairly well, and it's certainly been useful. I've used things out of pip. I think other people have, and it also just makes it more like Python on other systems that people would come to expect, rather than you have to install everything differently. One of the things that doesn't come through pip because it needs to compile things, though, is Pygame, which I will mention. So I think we sort of decided. Andrew Rawnsley was quite keen that we had Pygame. I think it's quite good to show off because it's graphical. It's graphical. It's got sounds, and I think people quite like writing things in it. Because actually I was quite surprised RISC has SDL, so it wasn't actually too bad. It pretty much just builds. I think at the moment we've got SDL 1.2. I've seen bits about SDL 2 being looked at least. I don't know what happened with that. But yeah, Pygame pretty much built and the things that things it didn't build and things I didn't expect to build. I think the camera stuff doesn't work because there's no camera interface. And there are, I think, some bits which use Numpy, which because I don't have Numpy built, didn't build. But there, the standard Pygame itself builds and works. I did have to do a similar-ish thing to the Python import system in Pygame, where you would kind of say, I want to use this font, and you describe it as a true type font, which would be in your game, so in your code, so you'd be fonts.ttf, and then of course it would complain, so because it couldn't find that. Rather than go and update all the examples, I did put a bit of sort of special casing in to do the same. If you can't find the file you asked for, try swapping the last dot for a slash and try again. So the basic idea of that was you could just take the examples and run them without needing to mess about with going and changing all the slashes for dots, which does get rather tedious. Where's my... So I'm going to vague attempt to show that. This is pretty sure it's installed on here. That's why I find it not. Pygame. So buried up in the depths of Pygame are the examples. There's some little run files. So these are really just run Python with the script. It redirects to null because otherwise it will print something on the screen, which then messes up the STL library, I think, so it quits your application, which is not very useful. There you go, so that's a Pygame window. It's a circle. What we can do with that? Quit it. The one I usually use as a demo is Aliens. It's not going to work very well over VNC and then over Zoom. But I'll quit that. But that just pretty much just works. So the run file just runs the example. I think the example works as is. So usually you can just run it, but if you just run it, you'll get you get something printed on the screen, which then I think upsets the SDL stuff. So that I'm pretty sure that file is just as it was in the. I need to update my strong end so it uses the right type. There we go. I think this works untouched. So that's quite a good, that's quite a good thing for anybody who's trying to try examples out. We haven't got to nonsense around too much. It's probably going to be I'm trying to find if there's a. Yeah, so these file names here are what I've kind of had to magic around, so you don't have to go and change all the file names. Just because again, there's so much of it that to have to say to somebody, you need to go and change all your file names is going to get pretty tedious. I started doing it and then thought, I can't be bothered. I'll handle it elsewhere. So that was Pygame, and that got, that was something else that we kind of wanted to get working, and I think it pretty much does. If SDL2 comes off, I think there's a newer version of Pygame that goes with that. So that was that. But something else and one of the reasons I sort of started looking at Python is I thought, well, can I can run things for different platforms on it, and I can install things on pip now. But one of the drivers for this was, well, can I use it to write native RISC applications? I found it was a quicker language for doing development in, so it made more sense that, well, okay, can I write RISC applications in this? I'm going to go back to my let's share my screen again. Use the other screen. Get my head around this. So where to start with that? So the Python 2, previous Python 2 implementation had a module for calling SWIs, and if you've done any sort of programming on RISC, you'll know that where you do anything pretty much is to call a SWI. So that's kind of get into the operating system. So rather than define a new SWI interface, I pretty much took the one from Python 2 and updated it. I think it took a bit of fiddling about because Python 2 to 3 is quite a big change. The interpreter changed under it. So I took the SWI system we had in Python 2, updated Python 3. I had to add sort of support for Unicode strings because every string in Python 3 is Unicode. At the moment, I think they just get encoded Latin 1. So, we're going to ignore things. But around the interface could stay pretty much the same. I also added the ability to use unsigned and signed integers. I think it used to just do signed. This became apparent when I tried to use the Toolbox, which I'll get to later, because it gave me a big number back and then it treated it as a minus number. Not very confusing. So the way in Python you call SWI, import SWI. I think actually SWI, you say import, but it's actually built in to the interpreter because it's used within Python itself now. So I didn't want to have to try and read something in from disk that I was using in the import library, because it's a chicken egg type thing, isn't it? And I need to call a SWI, but I need to load the SWI library, but I can't do that because I'm writing the code that does the import. So anyway, so the simplest one is that's just called in that's really simple SWI. The parameters are, you can probably guess, the SWI you're calling. The next one is a kind of a format specifier. So you can say if you're passing it strings, integers, blocks. There is a notion of a block, which is basically a blob of data. Which you can fill that in Python, you can pass it to the SWI, it's in a form that the SWI can work with. You then pass any parameters that you want, and it returns anything that you've asked for back. Of course, being RISC, you can do crazy things like this. I won't press return. You probably guess what I would do. That was an interface into using RISC itself from Python. I'm going to delete that line in case I do press return. That'd be a bit embarrassing. So onto that. On top of that, I then decided that, well, if I wanted to write a RISC application, the desktop is a desktop application. Probably the Toolbox is a fairly sensible place to start. No, not everybody is a particular fan of the Toolbox, but it was an easy thing to start with. You can get a lot of the stuff done for you, which you'd have to do manually if you're using more low-level systems. You can just call the WIMP SWIs directly. Show the Toolbox library. Now, there's been a few. Installed. Yes. There has been today a new release of the Toolbox library, which this is it. It's really just an extension of the previous version. There's been, I think, at least one other release kicking about. It came with the Toolbox test application, which is now wildly out of date and needs fixing. But this is really just a way of talking to the Toolbox. Code, talking to Windows. There's an example of calling a more complicated SWI, which is Toolbox. They're all Toolbox miscop type calls, but That's the specifier that says what parameters you're passing, and these just map to the registers as if you were calling it in BASIC or whatever. In fact, 0 just means set it to 0. I've used I for unsigned. Little I was signed before, so I've tried to keep the interface the same as before, such that if you'd used the previous version, your code would still work. B is block, so that's the block is really just a chunk of data which you then set bits of it. Obviously, if you have to kind of have the code, the code has to set up some data, but the RISC can understand. If you give it a Python object, it's going to get very confused. So that's a fairly this. The things after the semicolon is what's returned. So there's one there that returns an integer, basically. So that's sort of the SWI handling stuff, and where it's used for the toolbox. I've not done all the toolbox stuff. I've basically been doing bits of the toolbox that I've needed to do as I go along. If anybody wants to write stuff with the toolbox, then please do shout. It's an ongoing project. It's all these things are really. There is an application I've written with it, which hopefully will run. So there's slightly more. It's a proper desktop application. It's got menus. It's got choices. It doesn't do anything. by the window, but it's a departures board, so I can do that one. It tells you the trains that are leaving from any given station for the next hour or so, couple of hours, I think. It's got a resizable window. So it's all done with the toolbox and Python. So that bit scrolls, that bit doesn't. That was quite a challenge to get to work. That was just a WIMP programming challenge, I guess. And it's also got an arrivals board, so you can. And this is a search as you type thing. So I'll do. Let's get arrivals. So that's you can keep opening windows. I'm doing Wakefield because it's a Wakefield user group.
Doesn't look like a good time to be travelling by train.
Was that so? This part of this is just sort of messing about, trying to demonstrate different things or test different things. You can also save the data, actually. So you can export. And that's actually really easy to do in Python because there's a library for writing CSV files. So it's a tiny bit of code. You can save out the data. It's not particularly useful to have that data, I guess, but it's just a quite an easy bit of the actual code to do that. It's pretty straightforward. I'll probably show you the code to do it. I found this using the toolbox and Python does work pretty well together in terms of doing. Got it running this one. So the code to the export is just that. In fact, that's actually the save as object in the res file. When you save the file, the library will call you here. Just open the file, write it, close it, done. So all that stuff's handled for you, which is, I think, one of the great advantages of Python over other, certain other. Just there's so much there that you can just use without needing to write your own code to do this, that, and the other. So that's, I guess, for me, that's that's made this program pretty quick to write. Which has not been quite as quick as it could have been because I had to write the library at the same time. The interface to the data is just this simple thing, and it just imports it uses a Python library that I've got from pip to actually talk to the server and download the data. I think it gets you some JSON data. You can then use a Python library for that, so you can pick that apart and you just get your data out. And it's to do that in sort of BASIC or something would have been a real nightmare. I wouldn't have attempted it. Probably been easier in C, but again, it's lots of libraries that you have to use and pick up. Whereas in Python, it's just there. So that's right. So that's a desktop application anyway. That's just in Python. Where's it stored? This slightly obscure format of stations file. If you load into a spreadsheet, it's sort of three sets of columns, but that's just downloaded from the National Rail website, and that's just imported in Python. It just load it up. Probably the code that does it. Just opens the file, reads the data in, shoves it into a container. Test code now. So that's I think that's certainly what I found to be the big advantage using Python is you can get stuff up and running pretty quickly. Which if you're don't have a lot of time or it just makes a big difference. So that's writing desktop applications. So has anybody got any questions? I've been talking for ages and I want a drink. Anyone say anything, please do so now. Yes, not. Go on.
Unshare your screen.
Yes. The wrong mouse. There we go. Now we've got back to people. Okay, that's better.
How much optimization have you done on Python 3? Because I've got a Pi 4 and I've run the same programs under RISC-OS and under Linux, and there's still maybe a 1.5 to 2 times speed difference between them.
I've not really done any explicit optimization. I've just kind of taken the code that was there. I mean, what sort of programs are they that are?
They're mostly CPU-intensive, fairly trivial programs, problem-solving things.
Yeah, I suppose RISC-OS is only ever going to use one core, but that's.
Yeah, I mean, they are single tasking.
Single task anyway, so.
I have got a multitasking version, but I've got a special library for RISC-OS that just pretends it's multitasking, doesn't.
Yeah, does one thing at a time. Exactly one thing at a time.
It's a multiprocessing library that doesn't, basically, just so that you can have those calls in the code and not use them.
Yeah, so just sort of stopped out really to not do anything, but you can make the call and it just ignores you.
Yeah.
There's not. I mean, I think it's built with optimization, GCC optimizations on, but I don't think it's any other particular thing it does in terms of optimization. I guess the stuff that I would sort of expect might be slower, be file access, but once you've got stuff loaded, that's sort of not really going to change.
Stunned silence.
Silence. Oh, I'll just keep talking then. So the next bit I sort of wanted to sort of touch on, I guess, was what from here, what now? I do have. Let me just wrong mouse.
Sorry, there's stunned silence because I had to go and get the power cable because I have like 2% battery left.
Oh. Yes, with a laptop, you get a bit of leeway on power cables.
Yeah, I'd normally run it on my desktop Linux machine, but unfortunately, once you've upgraded the kernel, Zoom doesn't want to work anymore. Reboot the machine first.
Oh, yeah, dangerous that. It's going to show back into this one. Right, good. I need to share my screen again. What's this thing? Let's. Right, this mouse. So the next bit I sort of want to touch on was what now, what next. So by way of example, though, that's a bit bleeding edge. But this is the latest version of Python is Python 3.10, and that these runs. This it's probably not quite ready for release, but it builds the extensions, it builds obviously the interpreter itself. I do intend to sort of package this up for anybody who wants to try it. The stuff that's not in this version yet is things like pip or Pygame, I guess, but I guess pip would be the first one to do, just because I've not got around to doing it. I think the version of pip that's used between 3.8 and 3.10 is changed, so I'll need to sort of reapply all my changes. I've not got around to trying it, but the work in porting 3.10 starting from 3.8 wasn't too onerous. It pretty much just merges in. I mean, there's always something you got to go and fix, but it's pretty much a couple of. I'd say it takes a day, but it doesn't mean it's a day's work. It's just doing other stuff at the same time. So that's I guess the next version that I'll probably be releasing. I do have a newer 3.8 to release as well, actually. I've kind of skipped 3.9 just because trying to maintain 3 versions is just a bit silly. So I just jumped to 3.10 when that came out. Always seems odd that 3.10's after 3.8, but it is. When you write it down, it looks like 3.10, but it's not. It's 3.10. So that's just trying. Really, I guess this is just trying to keep up with the latest Python, so we don't. The RISC version doesn't drift too far from the main version. If I can keep it roughly the same, then if you don't get these massive changes that build up, then it's really hard to apply them all.
Well, you're ahead of most Linux distributions. They're still on 3.9, so well done with that.
Yeah, it's one. I just skipped 3.9. Well, I think I did build it once, but I thought, well, by the time I got around to trying it again, the 3.10 was out. So I just jumped 3.10.
But it's a small but welcome speed increase on that. It's the fastest version since 3.5 plus 1. So,
So yeah, so I will eventually get that sort of package and released. In terms of other stuff, it would be nice to build it with VFP and Neon extensions. At the moment, it's just built with FPA. That would probably speed things up, at least it does floating point. However, you do have to be using VFP is kind of all or nothing. Everything could be built with it, or nothing could be built with it. So at the moment, I've kind of dodged that one by not looking at it. But it's probably something is worth looking at some point, especially if you're doing any sort of floating point stuff. There's always a slight issue that you've got to support. That a lot of people use RPCMU, which doesn't support VFP. I've written VPN in my notes, which is very silly of me. VFP, but there's that sort of wrinkle that means you kind of can. We're going to have a non-VFP version anyway, but other packages seem to do it. So there's no reason why it can't be done.
Python 2.7.16 has a VFP and a standard floating point version, so that's quite good.
It is doable. I think it's anything that gets compiled, so yeah, it should be. It's kind of on my to-do list, but it's never quite got far enough up. Something that I think someone actually mentioned in the chat. Lost. I apologise. Was can we have a copy of this? This desktop departures thing. Yes, I can easily release it. However, one of the things that you can do on other platforms with Python is a thing called freezing, where you take the program that you take your program, you run another program on it, a script on it, that will then take your program, everything it needs, bundles it together into one executable, and you just ship that. Then someone will just just run it, and it's there. You haven't got to install things. However, that's quite a big chunk of work, I think, to get that to work on RISC. But it would be nice to do that. So you could just write something in Python and ship it. And it's just going to be a self-contained thing, relatively large, but self-contained. You don't have to install anything apart from you probably have to install the basic libraries, but you wouldn't have to pip install anything. You just take the thing, run it, and you're away. There are programs for doing that, but they're all targeted at Windows and Linux. So, and RISC doesn't quite fit at all like either of those. So there might be something that can be done that's maybe not quite as complete, but would be useful. So that's something that's also kind of on there. Would be nice to have. To just unshare this window. Wrong mouse. Stop share. Go back to that. Oh, we got more questions. The desktop departures thing is probably the thing I've been using to develop the Toolbox library. So it's probably the best demo app, at least for RISC native programs. What things are missing on the RISC that have made it easier? Probably some sort of process management, actual multi-threaded. I know the Unix lib stuff does a version of pthreads, but it's obviously it's limited because it's a single thread. It's a single threaded operating system, single threaded, single core. I guess the thing that I think I have sort of started coming across is that because RISC-OS doesn't really have any notion of different processes and process control, and everything's got the same environment. So if you change directory in one process, it changes it for everybody. So that it's not been a big issue, but I have sort of thought, oh, that could break. But most of the stuff in Python actually just tends to work with relative directories, so you kind of get away with it. But unlike on Linux, where you can have two windows, two different directories with two different sets of environment variables, it's all general. It's all one for everybody. Someone asked what the requirements are. I believe it works on an RPCMU. Pretty sure it works on RPCMU in anything after RISC-OS 4. It'll need long 5, so you can't go any further back than that. And it needs the ELF libraries. I'm guessing the main thing you need is enough memory. Which if you've got an emulated system, is fine. You can just drag your slider for more RAM and think how much it would have cost you when you had an actual RISC PC. In terms of Raspberry Pi, anything will run it. I think any Pi will run it. I tend to use about 8 meg WIMP slot just because that's enough. It would probably run in less. I've got my Raspberry Pi's got 2 gigs of RAM. I don't really care. So in terms of requirements, that's enough. Another question. GCC 10. Yes, I probably will. I'm still using whatever the current one is. Store. Oh, no, it's not installed there. Yeah, but the current one is just because trying to reduce the amount of stuff I have to do with having a different compiler. I presume GCC 10 ought to just work. I'm pretty sure if you compile Python on Linux, it will use GCC, whatever the latest is. So there ought to be. That ought to just work. I've not tried it just because I don't have GCC 10 to try it with. It does build natively on RISC-OS rather than the cross compiler, so it also takes quite a while. The reason it does that is part of the build process is this the import lib step, which it runs. Kind of builds most of Python, uses that to import the import lib, convert it to bytecode, and churns out some basically binary blob in a header file for the compiler. So it also builds on RISC-OS. I've done most of it on my laptop, and that's in ARM book, so don't always have a Linux system to hand. Another thing on my sort of would be nice to do list would be to try and get some sort of automated builds running the tests. Now, there are tests. It does run some of the tests, but at the moment, the PyTest, some of the other test suites will do the usual thing of look for files that end in .py, and then, of course, I don't find stuff because it all ends in /py or it's typed Python or something. So a bit of fettling to do there. I guess the other thing would be we currently have, I think, a hold of 2 RISC-OS libraries in PyPy, which is the Python system. One's the Toolbox one, and the other one is the one for doing sort of VDU style BBC graphics. Which, if anybody's read Archive, I can know about that one because there's a picture there. It is possible to write and upload a library using just a RISC-OS system, or at least it used to be. I tried it earlier and didn't work, so obviously upset something there. But that's something I need to fix that. But that would be a useful thing, I think, for maybe It'd probably be something I need to probably look at is doing a worked example for people who might want to do that, to say I've written a bit of Python code that's useful for doing something. How do I get onto pip? Well, pip uses the PyPy system, which is a Python package index. It's PyPy. But anybody can write packages for that. So if there's interest in that, I should probably sort of do some notes, even do a talk about doing it. Whether that's of any use to anybody, I'm not sure, but it would. If you've got something that's of use, then stick it on the Python system. I mean, other people can use it without sort of need to download your code and stuff. So that's yes, that's kind of my further plans, as it were. I missed it from my notes. I think. Yeah, so I think the main tricky bit has been file names. Basically, file names and I guess process, to some extent, process control, but file names has been the just because RISC-OSS is so different, and then everybody else just assumes that file names are slash separated from some version of slash, and then have dot something at the end. And actually, the packages have the versions encoded in them, which means you have dots in the directories as well. Which, of course, on RISC-OS you have to swap to slashes or something, and it gets horribly confused. So it's quite often when I was trying to get it to work, I'd end up with a weird directory tree of Toolbox library -2 in there, be a directory called 0, and then a directory called 0. That's not what I wanted. But that's I guess that's that's where RISC-OS differs enough that you just have to kind of work with it, really. So I've waffled on for quite a long time, longer than I anticipated when I wrote these notes. So I hope it's been useful. But if anybody has anything they wish to add or ask, please do shout. Then I can have an excuse to have a drink.
Can I ask a question?
You can.
It's obviously an interpreted language. How does it compare speed-wise to, say, BASIC, if you were just doing, I don't know, sort of processing text files or strings or something like that? Is it as quick as BBC BASIC would be?
Oh, I'm not sure. I'd imagine, I guess to some extent it depends what you're doing. I mean, there are. I'm trying to think if there are any text. You kind of get quite a gain because you can. There are plenty of libraries which have got C components in them. So if it uses something that's been written in C, or you've written in C, if you want, that just goes at the flat out rate that C would go at. In terms of sort of data processing, I've not really done any tests, I guess, to sort of quantify the two. I would probably say in terms of running speed, I'm not sure, but in terms of development speed, I personally find Python a lot quicker. So if I want to do something, I can write a bit of Python that does it, and there are libraries there. You can just call them. There's lots of lots of processing stuff available that if I want to do something, I can probably get it done quicker, even if it takes longer to run. If you see that sort of a trade-off of, well, I can just write it, I can just get the code written and run it. It might take a little bit longer to run, but of course it depends. If you're running it every 5 minutes, that's an issue. If you're running it every 2 years, if it takes longer, it takes longer. It's not going to be massively longer. So I think that's sort of where I've seen the benefit of Python as a, just being able to get stuff up and running quicker. So, I mean, imagine if you're, for a lot of processing stuff, there's probably, libraries around in Python that are probably fairly well optimized for doing it, because it's kind of a fairly standard use case for Python is to, I certainly know there are things like Numpy, and if you're doing numbers, that just handles massive data sets of numbers really well. Got a feeling it doesn't work on RISC-OS yet, though. Had a feeling it sort of built, but it didn't actually work properly because of the slightly obscure way that FPA works with its number representation. I didn't really look into it any more than that. Perhaps if we go the VF floating point route, then that would help anyway. What questions? Good. Yeah, so it is like everything a work in progress, and the language itself keeps on evolving. So there's trying to keep up, I guess, is the main thing. At least pick what we can of the upstream stuff and make what we can work within RISC-OS. It's different enough from POSIX, Windows, Mac, Linux, whatever, but I don't think we're ever going to get everything exactly working the same, but that's probably an unreasonable goal. But sort of my aim is to get it to be working enough that you can do useful stuff. And that's probably a reasonable target, rather than saying, you can do anything in Python or RISC-OS. It's probably not going to get to that point, probably ever, to be fair. But if we can make more stuff work, then I think that, sorry, went to screensaver mode. Then I think it can be, certainly hope it can be a useful language for people to do stuff in. But if you need to write something on RISC-OS, then Python is an option. Both for people who are, existing RISC-OS programmers who want to do something, maybe existing RISC-OS users who want to maybe not really done much programming, possibly people from other systems who want to program RISC-OS. There's varying categories of people I think it might be useful for. So obviously if you want, flat out performance, you're probably going to need C, but often you don't. It's probably close enough to be useful enough without needing to resort to compiling code for stuff. So I mean, I don't know how much the I don't know how much slower it is or faster it is in other languages, but I've not. I guess I've not done any comparison to the like test, but just kind of go on the feeling it's probably fast enough for most of the stuff I'm doing. So it's fast enough is good enough, I guess, in that sense. Anybody else got anything to add? I disappear off screen for more water. Stunned silence.
Well,
or everyone's gone to sleep. I'm not sure which.
No, there's definitely some of them are moving. They're definitely moving.
Oh, it's a start.
Anyway, thanks very much, Chris. I nearly called you Steve then. I've no idea why. Chris, I know who you are.
Yes.
You lost me fairly early on, but that says a lot more about me than it does about you. But thanks very much anyway for being our guest. And you're not very far up the road.